3 impact drivers, 12 months. Thousands of structural screws, lag bolts, and heavy-duty fasteners driven into everything from glued OSB to engineered timber. And the winner is not the one sitting on every professional's tool belt right now. We tested the Milwaukee M18 FUEL Gen 4, the Flex 24-volt brushless, and the Ryobi ONE+ HP side by side. Same conditions, same fasteners, same operator, for a full 12 months. And what we found does not just tell you which driver wins, it tells you why the industry is built to make sure you never find out. We tested Milwaukee, Flex, and Ryobi HP Impact Drivers over 12 months, and there is a clear winner. Before we get to a single dyno number, there is something the packaging will never tell you, something that changes everything about how you spend your money on tools. Milwaukee and Ryobi share the same corporate parent in many markets. Both brands are under the Tektronix Industries (TTI) corporate umbrella in many markets. TTI acquired Ryobi's North American operations in 2000 and Milwaukee Electric Tool in 2005 and reports multi-billion-dollar annual revenue. Since those acquisitions, the same parent company has marketed tools across multiple price tiers. Product differentiation appears to reflect distinct market positioning rather than identical engineering. Now here is where it gets interesting. TTI operates separate brand strategies and product roadmaps for its different tool lines. Milwaukee's higher-end lines tend to use more metal components and higher spec bearings, while Ryobi's consumer-focused lines often use more polymer components and cost-optimized bushings and electronics. Teardown reports and spec comparisons illustrate these typical differences. They are not identical products. The product strategies reflect different trade-offs between cost, performance, and durability across price tiers. Flex, on the other hand, answers to nobody in that family. Flex is owned by the Chervon Group, a Nanjing-based manufacturer that started as a white-label factory in 1994, acquired the German Flex brand in 2013, and has since built some of the most automated smart factories in the power tool industry. 11-deck robotic vertical warehouses, integrated manufacturing execution systems, robotic arm assembly lines that eliminate human precision error in motor winding. Chervon is not playing catch-up. Chervon is trying to burn the house down. That corporate context is not trivia. It is the entire reason these three tools perform the way they do. Most reviews hand you the numbers. We are going to tell you what the numbers actually mean. The Milwaukee M18 FUEL Gen 4, model 2953-20, is rated at 2,000 inch-pounds of torque, 3,900 RPM, and 4,400 impacts per minute. It weighs 2.2 pounds and measures 4.5 inches from front to back. On paper, that looks like a compact powerhouse. But here is what Milwaukee did to get there. They compressed a high-output planetary gear system and a heavy-duty hammer and anvil mechanism into a chassis so tight there is virtually zero structural safety margin when the tool operates at its absolute limit. Independent testing has documented repeated catastrophic gear shearing under sustained static load. The hardened metal gear teeth, the very components responsible for transferring all that rotational force, have proven highly susceptible to failure when the tool is pushed beyond its intended application window. There is also a documented collet retention failure on the Gen 4. Under heavy load, the quarter-inch quick-release collet releases driver bits, not occasionally, repeatedly. Enough that repair guides for this specific failure exist across multiple independent platforms. Milwaukee built a Ferrari engine and put it in a chassis that cannot always survive the race. The Ryobi ONE+ HP, model PBLID01B, tells a completely different story. Ryobi extracted 2,200 inch-pounds of torque and 4,000 impacts per minute from a standard 18-volt platform. That is a higher peak torque rating than the flagship Milwaukee, from an $89 tool. The upgraded brushless motor stator and die-cast gear case for heat dissipation are doing real engineering work here, not marketing work. Yes, the top speed is governed to 2,900 revolutions per minute. Yes, it uses standard bushings instead of sealed bearings. Yes, the bare tool weighs 2.33 pounds, slightly heavier than Milwaukee. But in single-burst static torque applications, this tool has successfully sheared rusted 7/16" bolts and competed directly against tools costing 3 times as much. The performance gap between professional and consumer tiers has not disappeared, but it has narrowed to a point that should make every premium brand deeply uncomfortable. Then there is Flex. The FX1371A runs on 24 volts, 6 lithium-ion cells in series instead of the industry standard 5. That single architectural decision changes everything downstream. By Ohm's law, higher base voltage means the motor generates greater total wattage at lower comparative current draw. Less current means less heat. Less heat means the tool does not throttle itself into submission when you are driving a 3-inch lag bolt into engineered lumber at the end of a long day. But the voltage is only half the story. Flex uses stacked lithium pouch cells instead of the cylindrical 18650 or 21700 format that every other tool on this list relies on. Traditional cylindrical cells have a single physical tab. Energy enters and exits through one point. That creates internal resistance. When your impact driver demands a massive current surge to break a rusted fastener loose, the cylindrical cell resists that discharge. Voltage sags. Heat builds. The tool's protection circuits step in and rob you of power at exactly the moment you need it most. Flex's pouch cells use a multi-tab internal structure. The resistance is dramatically lower. The current delivery is uninhibited. The result is 2,500 inch-pounds of torque, 4,000 revolutions per minute, and 4,450 impacts per minute, class-leading specifications across the board, backed by a battery architecture that can actually sustain them. Here is what the empirical testing revealed after 96 comparative runs across 12 months of controlled conditions. On medium load, high-speed applications driving standard ledger screws into glued OSB, Milwaukee wins, 5.9 seconds average. Flex came in at 6.7. Milwaukee's hyper-tuned anvil mechanism and extreme rotational velocity are exactly what this application rewards. If your daily work is driving structural screws at volume, Milwaukee's engineering intent aligns perfectly with your use case. On high-load lag bolt driving, 8 by 3/8 inch lags into stacked OSB, Flex wins decisively. 5.07 seconds against Milwaukee's 5.8. The pouch cell architecture delivers sustained current without thermal throttling. Milwaukee's cylindrical cells begin to sag under the sustained draw. The gap is not enormous in isolation. Across a full working day, it is the difference between finishing the job and fighting the tool. On breakaway torque, 8 grade 8 hardened steel nuts torque to 150 foot-pounds, Milwaukee wins again, 3.02 seconds against Flex's 4.08. Short burst, maximum kinetic transfer. This is Milwaukee's home territory. For our absolute torture test, an application no sane contractor would put these quarter-inch hex drivers through daily, we used a multi-material bit to drill 3-inch deep holes into 4,000 psi cured concrete. We did this purely to force thermal throttling. The result: Flex wins by a significant margin, 5.77 seconds against Milwaukee's 7.74. This is the most thermally demanding test in the battery. Milwaukee's cylindrical cells overheat. Flex's pouch cells do not flinch. Ryobi does not win any of these head-to-head speed tests outright. But on static dyno testing, it reliably achieves its 2,200 inch-pound rating. It removes heavily rusted lug nuts. It consistently outperforms older brushed professional tools that cost significantly more. For $89, the Ryobi HP is not a consolation prize. It is a calculated disruption. There is a conversation that none of these three brands want to have with you. It is about what you are actually paying for when you choose a tool. Milwaukee's Gen 4 durability crisis is real. The documented gear failures under sustained dyno stress expose a fundamental engineering trade-off. Compactness was prioritized over structural safety margin. If your work regularly involves sustained high-torque applications, the 4.5-inch chassis is working against you. The Gen 2 and Gen 3 Milwaukee Impact Drivers, less compact, less celebrated, have a significantly better track record for long-term reliability under heavy use. The upgrade cycle that pushed you toward Gen 4 may have moved you away from the more durable tool. The Ryobi HP line proves that the plummeting cost of brushless microcontroller technology has fundamentally altered the power tool hierarchy. The performance gap is closing, not because Ryobi is secretly using Milwaukee components, but because the underlying technology has become democratized. TTI's internal firewall is real, but the laws of physics do not respect brand positioning. Flex's 24-volt pouch cell platform represents the most significant battery architecture shift in a decade. Theoretical data suggests pouch cells offer 200% greater power delivery, 300% longer battery life cycle, and 100% faster charging times compared to standard cylindrical formats. These are not marketing claims. They are electrochemical properties of the cell geometry. The question is not which tool has the best spec sheet. The question is which tool's engineering philosophy aligns with the actual demands of your work and which corporate parent's strategy is quietly working against your long-term interests. So here is the honest answer after 12 months. If your work is urban, high volume, and speed dependent, driving ledger screws, breaking fasteners loose in short bursts, working in dense environments where the Waze equivalent of tool data is a dense community of real-world feedback, Milwaukee wins on raw speed and compactness. Just stay away from sustained static loads and consider whether Gen 2 or Gen 3 serves your durability needs better than Gen 4. If your work involves sustained heavy loads, concrete, long lag bolts, or any application where thermal management is the limiting factor, Flex wins. Not marginally, structurally. The 24-volt pouch cell architecture solves a problem that 18-volt cylindrical platforms cannot solve without a fundamental redesign. And if you are protecting your budget without sacrificing peak torque output for standard professional applications, the Ryobi HP is the most disruptive tool in this test. The fact that it shares a corporate parent with Milwaukee is not a scandal. It is the most honest proof that the performance premium you pay for the red brand is increasingly a brand tax, not an engineering tax. The clear winner depends entirely on what you are building. But after 12 months, one thing is certain. The tool industry's most comfortable assumptions are being dismantled from 3 different directions at once. Drop your current platform in the comments, tell us your use case, and we will tell you exactly which of these 3 tools your money should be on.